Time travel has long captured the imagination of humans, and has been a popular concept in science fiction for decades. While time travel remains purely theoretical at this point, scientists and researchers have proposed several methods that could potentially allow us to travel through time. In this video, we will explore the most popular methods of time travel and the scientific evidence that supports them. Time dilation. Time dilation is a concept that arises from the theory of relativity, which was proposed by Albert Einstein in 1905. According to relativity, time is not absolute, but is relative to the observer's motion and gravitational field. This means that time passes differently for objects that are moving at different speeds or are in different gravitational fields. The most famous example of time dilation is the twin paradox, which imagines two twins, one of whom stays on Earth while the other travels at near light speed to a distant star and back. When the traveling twin returns, he or she will have aged less than the twin who stayed on Earth, due to the effects of time dilation. This effect has been confirmed by experiments involving atomic clocks on airplanes and in orbit. While time dilation is not a method of time travel in the traditional sense, it does offer the possibility of traveling into the future. If we were to travel at near light speed for a significant amount of time, we would experience time dilation and arrive in the future, while only aging a few years ourselves. Wormholes. A wormhole is a theoretical passage through spacetime that connects two distant points. It is like a tunnel that allows travel between 2 points that are separated by great distances. The concept of a wormhole was first proposed by Albert Einstein and Nathan Rosen in 1935, as a solution to the equations of general relativity. While wormholes remain purely theoretical, they are supported by the mathematics of general relativity. However, the size and stability of a wormhole would make it difficult to travel through. In order to maintain a stable wormhole, it would need to be held open by exotic matter with negative energy density, which has not been observed in the universe. Wormholes have been popularized in science fiction, such as in the television series Stargate SG-1 and the movie Interstellar. In Interstellar, a wormhole is used to transport a spacecraft and its crew to a distant galaxy. Time machines. A time machine is a device that allows travel through time either to the past or the future. While time machines remain purely hypothetical, they are a popular concept in science fiction. The most famous example of a time machine is the DeLorean in the movie Back to the Future. The DeLorean is a car that has been modified with a time-traveling device, allowing the protagonist to travel to the past and future. While the DeLorean is a fictional device, it is based on the idea of a time machine that can transport objects and people through time. One proposed method of time travel using a time machine is based on the concept of closed time-like curves. A closed time-like curve is a path through spacetime that allows an object to return to its starting point in time, creating a loop. If a time machine were to create a closed time-like curve, it could allow travel to the past or the future. However, the concept of closed time-like curves is not without its problems. It would require the creation of exotic matter with negative energy density, similar to the requirements for a stable wormhole. In addition, closed time-like curves could create paradoxes, such as the grandfather paradox, in which a time traveler kills their own grandfather before they are born, creating a paradox. Black holes. Black holes are one of the most fascinating objects in the universe. They are formed when a massive star collapses in on itself, creating a region of space where gravity is so strong that nothing, not even light, can escape. While black holes are known for their destructive power, they may also offer a way to travel through time. One proposed method of time travel using black holes is based on the concept of gravitational time dilation. According to Einstein's theory of general relativity, gravity can cause time to slow down. As objects get closer to a massive object, such as a black hole, time will appear to slow down relative to an observer farther away from the black hole. If we were to approach a black hole and orbit around it at a close distance, we would experience time dilation, and time would appear to pass slower for us than for someone farther away from the black hole. This means that if we were to return to the observer, we would have aged less than the observer, effectively allowing us to travel into the future. While black holes offer the possibility of time travel, it would be a dangerous endeavor. Approaching a black hole would require immense amounts of energy, and the gravitational forces near a black hole are so strong that they could tear objects apart. Quantum entanglement. Quantum entanglement is a phenomenon in quantum mechanics where two particles can become connected in such a way that the state of one particle is correlated with the state of the other particle, even if they are separated by great distances. This phenomenon has been confirmed through numerous experiments, and it has been proposed as a possible method of time travel. One proposed method of time travel using quantum entanglement is based on the concept of retrocausality. Retrocausality is the idea that the future can influence the past. According to quantum mechanics, particles can exist in multiple states at once until they are observed or measured, at which point they collapse into a single state. Retrocausality suggests that the act of observing a particle in the future could retroactively determine its state in the past. Using this concept, it has been proposed that a time traveler could use quantum entanglement to send information back in time to an earlier point, effectively changing the past. However, this concept remains purely theoretical, and the idea of retrocausality is still controversial in the scientific community. While time travel remains purely theoretical, the methods proposed by scientists and researchers offer tantalizing possibilities for the future. From time dilation to wormholes, time machines to black holes, and quantum entanglement, each method has its own strengths and weaknesses. As our understanding of the universe continues to grow, it is possible that we may one day discover a way to travel through time, but until then, the concept remains firmly in the realm of science fiction.